This is Aditya, and he's going to talk to you about what goes around comes back around, exploiting fundamental weaknesses in, well, you can probably read yourself, right? Aditya.
Hi. Thanks, Ray. Thanks everyone for being present here, and since it's like 30 minutes, I don't want to waste the time, and let's get started. So today's talk revolves around the fundamental weaknesses and the real-time case studies that I've analyzed during the last couple of months, and that actually helped me to compromise the command and control servers. Basically, the overall idea behind this talk is to just understand how the command and control panels work and what kind of things we really require to build intelligence so that can be fed up into the automated solutions. But the primarily part we're going to talk about is penetration testing and how we're going to do it with respect to CNC panels. This is just a little background of mine. I got my PhD from Michigan State University, working in Silicon Valley for some security startup at this point of time. Just a shameless plug, but I read the book, so if you get a time, just go and fetch the copy. Yeah, so let's get started. I just put a disclaimer here, like all the things, all the research that I'm going to discuss in this talk is solely on me. It's not going to depend on what my present employer or previous employer is doing. So we'll see a lot of real-time, active links, figures, and those kind of things. It might be working this point of time, it might not be, but when all the case studies have been done, they were live and they were well tested. So all on you, you might encounter some active ones, you might not. So what this talk is all about. So the idea is here that we really want to understand how the command and control panels work, how they are designed. And if there is a possibility that there is a failure that we are not able to exploit them directly, what is the way, what are the different mechanisms we really need to opt to exploit them or to find a bypasses. And the idea is that to gather as much as intelligence as we can so that can be ported into automated detection solution or protection mechanisms. And that we'll see. So overall, if you look at the broader picture, the idea is to use the penetration testing in conjunction with the malware analysis to reap the maximum benefit out of this. So what is the rationale? So the rationale is very simple in this talk is like if you can't break it, so we need to bypass it. There are certain scenarios, timing constraints, and a lot of other factors which do not allow you to actually directly go ahead and exploit the CNC panels, even if you get some interesting. But either you have the time, then you have found some sort of interesting bypasses, you want to do that. And this has been done in this talk a lot, and we'll see looking at the case studies. So before going ahead, let's have an overview of what CNC panels are. So basically the name suggests command and control. The simple idea is that basically the command and control panels are being managed and operated by bot herders. And they are used to control all the bots that are present on infected systems across the internet globe. So the CNC panels send commands to those bots, they react according to those commands, and perform certain operations in the infected systems. Then they exfiltrate data back to the CNC panels. So if you are able to catch CNC panels, you can able to, basically dump down the complete botnet. But nowadays, majority of the botnets that have been taken down is usually through sinkholing procedures and all that. But in this particular case, you really need to find vulnerabilities, find bypasses, really need to understand what the component design is. So in order to, you can go ahead and do the penetration testing and get some things done. And so that's the basic idea of how the command and control panels work. And what the reason behind is that without these CNC panels, no botnets can sustain until unless they have like different architectures. That's what the point is. So let's take a look at what the CNC component have different sort of protections. Because they just cannot build a CNC panel that are just simply open and residing in the wild and anybody can go ahead, find the IP address and simply access it. So what they have done, they have implemented a concept of gates. So what gates are actually? Gates are basically an intermediate components that bots actually connect to, and then it sends all that data ahead to the main database. So if your system is infected and bot is residing on the system, the bot is going to connect to the gate, verify its identity, and then send the data to the gates, and that is also going to go back to the database. They have cryptographic keys like RC4 authentication keys. If you know that key, if you do a reverse engineer or perform reverse malware analysis, and then you get an idea, if you're able to capture the key, then you have the complete control of basically the CNC panel, because this key allows you to write or read any operations on the CNC server. There is also a login web page key which actually restricts or actually enables the bot herders to basically restrict the administrative interface of the CNC panel. So if you don't have an access to the CNC interface, you can't do anything, because there is a login key is established. You need to have that key. And so these are kind of different protection mechanisms that are being used by bot herders or malware authors to sustain and protect the CNC components. And I have listed a couple of the standard components. So there are gate there CP call as control panel, index.php basically try to restrict the access to the control panel.php. There's a configuration file. Then there is an installation directory, which actually takes care of the complete configuration of the botnet. So whenever a bot herder deploys the CNC panel on the server, it needs to configure it with the database, MySQL and all that. And then the installation component is just like an easy interface provided to the bot masters so that they can simply click and then configure the bot according to that. And there is an archiving files component. It might vary from different botnets to different. But in this case, these kind of components are heavily used in Zeus, ICE9, Citadel, and the Zeus Game Over version 3. So you find majority of these components persisting in the design of these botnets. Again, I want to lay stress on CNC gates because what happens that when the communication channel is set up between the bot and the command and control server, they come up with an idea that let's introduce a proxy layer between that so that bots do not get directly to the CNC panel itself. They're going to send a data to the gate, authenticate itself, then data is decrypted at the gate level and will be submitted back to the database and stored in the clear text format. So as it mentioned, it's like I think 90% of botnets, like HTTP-based botnets, use these CNC gates, and you will find it everywhere. So although they have some sort of built-in protection mechanisms to protect the CNC panel, like cryptographic keys, login web page key, and then gates, but to protect the source codes, they can use third-party protection software such as IronCube and Zen framework to implement some sort of access control policies kind of thing. But that has been seen. So this has been taken from some real-time server hosting the CNC panel. And that is they use this kind of protection mechanisms too. So in order to move forward, now we're going to dig a little deeper into the scenario of the real-time case studies. The idea is what kind of different attack models that one can use to attack CNC panel. The very generic model that we use, or maybe most widely used by the malware researcher, is to just reverse the binary, extract the RC4 or any cryptographic key out of it, and then try to upload something on the web server, and from there they can take control of the CNC panel itself. And that is the case, basically, uploading a C99 or C100 shells that actually give you access to the complete server. But there is another interesting factor that has been used nowadays, like obtaining a simple backdoor access to the hosting servers. I mean, if you compromise the server, whatever the number of hosts, sustaining on that server is be controlled by you. So that is also being used. In addition to that, there is a standard way where we are going to concentrate is design and deployment of command and control panel. What kind of mistakes the bot masters made, and what kind of components they are not securing, and how this is going to help us to just take control and take a next step and get to the server, or basically download all the stolen files and stolen data. We'll see that in a time. But all these attack models I've discussed in detail in the research paper that will be released after this, and you can fetch that and read the complete details on all these attack models. So let's get started. Start with the fun and profit scenario. So when I started doing research, there's always a scenario for performing some sort of reconnaissance or information gathering. Google Docs is always a good scenario. Although you will not get all the CNC panels that are persisting in the wild, but still for initial testing, you will definitely get some interesting patterns out of it. So I collected some of the interesting patterns after performing analysis for a couple of months, and there's so if you're going to go for Zeus, you can try for this potential. Google Doc, ICE9, Citadel, BetaBot, iStealer, SpyEye. They might change it, but if they're running in a default state, you can definitely get in contact with all these botnet panels. And that works. So in order to prove that, so I wrote a small tool with a Google docking check So if you look at this particular figure, and it ran the particular doc cp.php, and I just want to check the 100 records in the Google Doc. So it gives me a lot of listing, and whatever the listing URLs you're getting here with the 200 access is an open CNC panel. And similarly, you can also detect CNC gates using these docs. So I won't get too much detail into it, but I want you guys to just go ahead and give a try. You'll find a lot of open CNC panel that has been indexed by Google too. Now, to the real time. So what happens, I mean, this is just like for the previous one is for fun and profit, but what happens in the real time when you perform network analysis or network security monitoring and you deploy your, analyze a lot of network level traffic. So when you see this kind of traffic, this is a data exfiltration snippet taken from a live plasma bot. And it sends the data to, you can check to gate.php. And the data is actually in encrypted format, which is customized one. So it's not even sent over HTTPS. So you can check that it is being sent to panel.gate.php. And there is a rouse.com. So as I mentioned earlier, the data is being sent to the gate component itself. Now, based on the similar thing, I want to prove, the point that I want to prove here is that wherever the gate components are located, you will find the command panel 90% on the same server. So if you look at this part of thing, it's a live link. I'm not sure it's working right now, but when I tried it was working. So it goes into admin panel gate.php, you tweak things and you use build some docs according to your previous intelligence. And so you are being served with the CNC admin interface. So if they are sending the data, it means majority of the bot herders or bot masters, they are not actually restricting the access to the administrative interface of the control panel. Now, all this I try to see, like I've seen like a couple of botnet trackers, and when they used to find some URLs, pointing to some domains or CNC servers, there is certain specific cyber patterns that we really need to look into. It is always not a true fact that you are going to encounter only one CNC panel on one particular server. It's not true actually. So it's basically a kind of web application testing in this scenario on the URL patterns. Basically you can fuzz the links or do some sort of things. The overall idea is that even if you get the first link where the CNC server is hosted, basically the URL, you really need to find the pattern. As I give an example here, after the storage directory there is 2, 3, 4. So you're going to keep on iterating all those things. You can automate the process. But this is always, beneficial. There might be only one, there can be multiple. So when I tried this process, I found like there's like a multiple use panels hosted on a same server. And I tried it with some another one. So if you look at this screenshot, it's a WinLocker CNC panels. And you can still see that there's like a multiple hosted on the same server. So the idea is that being a penetration tester or a malware researcher, you have to keep digging inside in. You just cannot stop. Maybe just automate the process with Python code and just check what access rights you have for that particular web page. But you really need to detect whether there is a multiple CNC panels hosted on same server or not. So in order to prove this, there is just like a 1-minute demo. If you look in this particular one, so we are actually got access, not access, basically we are got in touch with the admin interface. And they have like a directory structure as image 9 or something. So the idea is that we're going to keep on changing the numbers. So if we do like 9, maybe I want to do 8, I still get the Zeus panel. So I started trying to do that. I think I got like approximately close to 8 or 9 CNC panels hosted on the same server with different directories. And so the 10 one was not working, the 11, 12, the 12 is not working. So the 7 is working, 6 is working, 4 is working, even 5 might not work. So the idea is that while performing pen testing, you have to dig you have to dig completely deeper into the scenario that you have to test much more with the passage of time. So now another interesting fact is that this is the kind of thing I have seen that leads to several bypasses in the CNC panels. The problem here is that either the components are not well restricted or by default, the design is in such a way. So the idea is that, I mean, if you understand the design of, Zeus botnet, understand the design of all the other, different botnets that are based out of Zeus, like Citadel, ICE9, so you can build the intelligence, or you can have the, idea that what kind of components are being used. So you can simply use that kind of intelligence to trigger an explicit check and see what kind of access you can get. So if you look at the screenshot at the bottom, so on the right corner, so there are a couple of things. I get an access to, there's a 200 HTTP responses giving me that these components are being actively present on the CNC server. So again, so what I did, performing those kind of checks, so this is a configuration, or you can say a default design kind of issue in Zeus botnet. So you can access the installation component directly. What that component does is that it basically allows you to send a one command, which basically refreshes the complete database of the Zeus panel. As a result, the notifications provided by the response, you will get a lot of direct paths where the files are being located and what kind of reports or what kind of databases are being structured. And that actually helps you a lot, because they might think most of the time the report folder is not well protected. And while you continuously go on the process of testing, you can harness much better scenarios. So let's take a look at this demo. So this is a CNC panel of Citadel botnet. So you can see this is it's using the same dock that we built earlier for the command panel. So first we try to use like a default case, like whether we can get access to it or not. It didn't happen. So as I mentioned, that installation directory is a very good scenario to check. So it gives me this kind of link. So it allows me to submit a command to refresh that particular database. So I update the database. So it actually starts giving me what kind of MySQL server it is running, and what kind of database, WebLizer kind of thing. So it gives me the complete idea how the botnet is being configured by the bot master. So if you go at the bottom, it gives you this link, the reports 347 something. Basically, it's a URL path to accessing the files directory or reports directory. So when we go that, we didn't find something into web injects, but it gives me all the web files, the modules, and other things so that have been configured for this particular botnet. So next I try to copy the reports folder. The basic difference between the Zeus botnet and the Citadel botnet, the installation component is exposed, but the Citadel botnets are actually using some pseudo-random number generator sort of thing to actually obfuscate the report folder. So when I copy that, it was exposed, and then there we shoot out, and we get all the data that how it has been, been sent by the various infected machines running Citadel bot. So it's a big file. It's just a one report from a one infected system, but you can try for different ones. So this is just a way of one. I mean, if you want to try this particular test, it will work for sure for the majority of botnet CNC deployments. So after this, let's talk about the port mapping of similar resources. The idea here is that, let's say you access a one particular domain, abc.com, right? It's giving you a forbidden error message, but then you find that there are other ports which running the HTTP, additional web servers. The idea is that if you think that this particular domain has this kind of component, like abc.com/resource-x, you have to actually check that access to resource component, all the HTTP web servers. And it usually proves beneficial. And let's take a look. I mean, so when I got an access to the cc9966.com, it started giving these forbidden messages. And from somewhere, from another network traffic, I got like they're sending some sort of data back to the CMD directory or resource. So when I access it, it's giving me a message of loading module, something from cc996.com, but the another path. So when I keep on trying differently, if you look at on the right side figure, I access that code on the port 81, but it started giving me, it actually allows me to download the command folder, or basically the command file actually. So when I did that, and so it gave me everything what I ever wanted. So if you go ahead and see, it's giving me a lot of additional information about how the MySQL password is and how the root password is all about that. And from there you can build additional intelligence to move forward or to run some sort of automated checks in that. But this is a very interesting check. Like, you have to keep on mapping different ports for different resources. Well, in fact, this is very insecure way the different bot masters are doing. Like, they're just deploying the CNC servers on the XAMPP installations. Basically, XAMPP is not even meant for deployment in a production environment, but they did that. What kind of proper problems you're going to have if you don't run a single command to secure XAMPP? All these kinds are listed here. You have a MySQL administrator root and sort of things. Even if you try to patch 2 or 3 issues in that, still there is a lacking that you can get access to the XAMPP servers, the running production environment. So I got this IP address and this direct URL from the network, and when I tried to access it, it started giving me this thing. Ask for the FTP access, password, and all that. Eventually, it was running in a default mode. So I had the username and password when I did that. So I got all the access to even the MySQL password, and there is a config binary too. So you can perform some another analysis and then extract the keys. So you really need to say, like, what is the underlying server where the CNC is also deployed. It's again a sort of penetration testing, but this really helps you to actually gain control of the CNC panels, even through designing some bypasses and all that. And let's take a simple look at it when we find that. So this is again a Citadel panel. And so when I found that there is a Webalizer directory was there, and then I got access to the XAMPP. It was running in default mode. I don't know why they actually go ahead and implement it, but another idea could be like they just want to have like an easy deployment of the CNC panels. Could be the reason by script kiddies, but this can be used, and so everything was exposed properly. So there is no need for even going into additional parts or some think too much about building some additional attack models. Whatever you have, just simply exploit it. And that's from there onwards you get the FTP access. So you provide the default credentials, and you are able to actually download whole the source code of the control panel. So cp.zip is there, so it's all yours now. So another interesting part is that root directory verification. It's a very, very simple test, but it proves beneficial when the botnet herders basically deploy the command and control panels on a dynamic hosting websites. And they are not well secured. It's just like they simply get ahead and get the domain name, deploy the server. So you can, if you get a hit on particular CNC server, try to go into the root directory, and you can still download the source codes, or at least you can have an idea that what are the CNC components are. Similarly, in 2011-2012, we find a SQL injection vulnerability in the SPI CNC panel, and it was like successful in even getting access and extracting data. And there are like a couple of other people, other good malware researchers in the field also doing this kind of thing, finding vulnerabilities in CNC panel. The idea is that, let's say from the previous case, you download the control panel zip file, right? You can then perform the static code analysis over it and try to find vulnerabilities. And that's how actually it is done. And can be done. So weak and default passwords, a proper list of weak and default passwords can allow you to access to any CNC component if it is configured pretty badly. So this is I got access to the site stealer panel running in a default mode, or default credentials are configured for that. So remote management shells, this is the last point I want to say. The rationale behind this remote management shells is that also if you previously discussed that in attack model 1, if you get the cryptographic key, you can still upload the any kind of shell on the target server. But with the remote management shell, there are certain scenarios. If you search properly the CNC server where the panel is being residing, so you can definitely get some sort of shells. Not in majority of cases, but it's always a good test to perform. So always try to search maximum I can do on the CNC panel. And if you go ahead, and this is the last demo I have. So So I have like certain code which I'll be, I upload on my website later down the lane, which I used in the, this kind of case studies. So I simply run that thing against that, and I just try to find out the exposed components on that server, and started giving me some errors and all that. So I got like a 200 access to the reports folder. I get to that folder as I discussed earlier. So there are a couple of directories listed here. I get into this directory. So usually if there's a cert directory, we don't want to go further because we find that there are like only certificates in it. But actually there is a data.php file. So it gave me a C99 access to that CNC server. And after that, it's like quite easy. You can dump the password, run some MD5 hash cracking and sort of things. So the idea in this particular test is that you have to really search well. I mean, if you are looking at the directory, it's a certificate. So, sometimes you stop. But no, I mean, just keep on digging the maximum you can, and you can get pretty interesting results. So after the conclusion is that there are a couple of other interesting studies have been discussed in the research paper, and you can fetch it from the Black Hat archives. And the idea is that to fight with malware, it is really important to harness the power of penetration testing and malware analysis altogether. So there are no shortcuts to fight against cybercrime. If they are doing something wrong, we might have to hit them back, and that's the way it is. So it's an arms race, but it has to be done. So the future work, it is an ongoing research. I have some other interesting stuff later down the lane to analyze the complete evolution of botnet CNC panels, like different malware families, and to direct new CNC panels for upcoming botnets, like how they look like, what could be their design and all that, and to perform data analytics on the data that is being stolen by the bot herders and that we have actually fetched from the compromised CNC panels. So any questions or queries? All right. Thanks.